Put it to record. And there we go. Guys, nice to see you here. Always good. Today we are going to use Tinkercad instead of Wolkey. It's another simulator. So I think the simulator has better features to attend us for this project today. So let's go there. If you want to go there, it's tinkercad.com. Okay, you can log in with your Gmail account in case you have it. Mine is in Portuguese. Yours will probably be in English. But here we have a button called Create. So I'll click on this button and I'll select the second option called Circuits. And then I'll click here. Let me just be sure that you are all seeing my screen. Yes, you are. Okay. And let me put my face here. Okay. There we go. Here, let's type Arduino, and then you'll have an Arduino with a breadboard already attached, which is cool. Okay, so
enjoy live.
There's someone with the audio turned on. Yes. Okay, but not me. I have to talk. Okay, now you can listen to me, right? Tochuku. Okay, thank you, buddy. Okay, so today you are going to learn how to work with sensors or any other analog input. Okay, and also how to convert values from analog inputs or sensors to PWM outputs. Okay, so this is something we are going to use all the time. For example, you can use this with a soil moisture sensor, water level sensor, with practically all sensors that don't have its own library. Okay, so to work with this, we're going to use the potentiometer. So here we have the search bar, and then we can attach a potentiometer here in our breadboard. And then let's work also with a LED as we've been working. Okay, here the right leg is the positive and the left one is negative. Okay, the potentiometer has 3 pins. This one and this one are positive and negative, or the opposite. You can put positive here and negative here, and the middle one is the programmable pin. Okay, so we already have here 5 volts, and the negative, I won't use this wires here, so I will delete them. And then I will take a wire, a negative here to this pin here, so I will change the color so then we don't get confused. And I will do the same thing to the positive pin. I'll do the same to the LED, so a negative already wire. Okay, there we go. This will be the first time we're going to use the analog pins. So we are going to use the A0 pin. Oh, please, there's someone with the mic on. Can you
Off your mic,
please turn
Chino,
off
off
your
your
mic?
mic.
Thank you. Let me just change the color. I'll put it yellow. So A0 goes to the middle pin of the potentiometer. And here I will put a wire in the pin number 5, and it will go here. Okay, let's go. So let's get started with the code. So here we have the code. Mine is in Portuguese, as I told you before. And instead of blocks, we are going to use text, which is the third option. Text. Say yes to continue. And here we have already some code. Let's delete all this code. Let's do it from scratch. So I will start declaring the potentiometer. So int pot equals to A0. Then the LED, int LED equals to 5, which is the pin attached to the LED. And I'll also create a variable called vol, which I won't give any value. Fine, setup. And then let's tell the Arduino board that we're going to use the pins A0 and 5. So pin mode pot, it's an input, and you have to type it with capital letters, don't forget. Pin mode LED is an output, also with capital letters. And the variable vol is not something we have to declare, it's just a variable, not a pin. And I can't forget about the serial monitor. So serial.begin 9600. Okay, so if you don't remember, we use this to monitor the values that we get from sensors or any other thing. Okay, in this case, we're going to monitor the values we are getting from the potentiometer. So let's create the loop function. And here we are going to use the variable vol to make an analog read from the pin A0, which we called pot. So let's use it. Vol is equal to analog read of pot. Okay, so let's just put a delay. A delay of 10 is okay. And let's read it. We can access the serial monitor here. Oh, and you can see here what is happening. Oh, sure. I'm not using the serial print. Oh God. Okay, serial dot print ln, and I have to print my variable vol. I forgot to do this. Serial dot print. Forgot the letter T, which I can't. Oh, I can't type. Let me see if it lets me type or not. It doesn't allow me to type. I have to, oh, now, no. Oh my god. Probably I'll have to refresh the page and then I'll lose everything. Yeah, I'll have to refresh the page and probably lose everything.
No problem.
Oh no, didn't lose. Okay, better now. Print ln. Let's access this serial monitor here. And there we are seeing the values we get from the potentiometer. So I'm turning the potentiometer. And as we can see, we are receiving values from 0 to 1023. Okay, so if you remember, the PWM outputs work from with values from 0 to 255. So for this, we have to convert, because I want to send the values to my LED so I can control the brightness of my LED with the potentiometer. But the potentiometer sends values from 0 to 1023, and the LED works with values from 0 to 255. So we have to convert it. So to convert it, we have to do something here. Let me stop the simulation. And then let's do this. Vol will be equal to map. This is the function that will transform the range that goes from 0 to 1023 to a new range that goes from 0 to 255. So as I already have the values stored in val, the first parameter I will pass is val. So val will store the map of val, and val works with values that goes from 0 to 1023, and I want to convert these values to new values that goes from 0 to 255. That's the idea of this. So now I will just cut this line from here and put this line here. Okay, let me just check. I think there's someone asking something in the chat. Oh, where's the chat? It's here. Which kind of simulator? Oh, Leonard, good morning. The simulator we are using today is Tinkercad. Tinkercad, okay, tinkercad.com. You can log in with your Gmail account and you start using it, okay? Let's go back here. So now guys, let's explain again. Vol is receiving the values that comes from the potentiometer, okay? We are analog reading the potentiometer, and Vol now here in line 14 stores values that goes from 0 to 1023. Here we are transforming these values that goes from 0 to 1023 to values that we can send to our LED that is in a PWM output pin, and these pins work with values that goes from 0 to 255. Okay, let's just see these values again in the serial monitor. So I will start the simulation. Now if I turn the potentiometer, you will see that the maximum value is 255 and the minimum is 0. If I put it half, it's something like 127. Yeah. Okay, you can see here the values. Okay, now we are going to send these values to our pin number 5, which named LED. And this is really easy. You already know how to do it. You just have to type analog write, and then we are going to say, oh, I want to write in pin number 5, which I called LED, and then I will send my variable vol. So then the LED will work dynamically. So again, I'm initiating. And our LED should be brightening, but it's not. Let's see what is happening. LED number 5. Let me just check if it is in number 5. Yes, it is. Oh, yeah. I probably burned my LED because I'm not using a resistor. So let's put a resistor here. It will be 100 ohms. And I'll also turn it to work here. And let's go again. There we go.
Yes. Okay.
Oh, there's something wrong.
Class of
Negative.
Ben. Ben.
What is happening?
Consciência.
There's someone with the
Change the
mic
LED
on.
too.
Can you please turn off the mic? Thank you. Pin number 5. LED. Why is it not working? I don't see any reason. LED is number 5.
Change the LED too. The polarity of the LED.
What?
Check the positive and negative of the LED.
Oh, here is the positive. And I'm sending it to here. Let's see. I will delete this LEDs. Let me delete this and delete this again. So let's rebuild it. Here is the negative. Okay, I'll also change the color. So let's put a blue LED. And one more time, turn this. Put it here in the positive. It will be 100 ohms. Cool. Pin number 5 will be here. Let me check my code one more time. Int LED, pin mode LED is an output. And here I have vol, which is mapped. And I'm sending vol to my LED, so it's correct. It should be working. Okay then. Let me see my projects here. I have more projects, and I think I've done this project before. Yes, here we go. Let me delete this. Let me wire one more time here and take a wire from here. New code, my servo. No, I'm not working with the servo. It's int lad equals to 5. After that, we can work with a servo, okay? Yeah, it's the same thing, but now it's working. I don't know why. But okay, guys, here, instead of vol, I have a variable called status, which is the only change. I don't know why. Or probably instead of analog write, I put analog read. I don't know. I really don't remember what I did, but it should be working as is working this one. Okay, so here I can write up and down our lad with the values that comes from the potentiometer. We can see the serial monitor here and half light, for example. Oops. Oh, here I was working with the servo, so I have to change the values here and then initiate one more time. Okay, now it's better. So it also brights more. Okay, so now we can control the brightness of the lad with the potentiometer. We can see the values here. You know now how to transform analog values that goes from 0 to 1023 to PWM values that goes from 0 to 255. So now what we can do, we can, instead of working with just a lad, we can work with a servo. So let's attach a servo here. Servo, micro servo, I'll let it here. This time I won't use the lad, so let me delete this lad. Okay, and the servo has 3 pins. The brown one is the negative, so I'll wire a negative here. The red one is the positive, so let me just change colors. Okay, and the orange one is the pin we are going to program. So one more time, it will be number 5, because remember, all these pins that have the till, this symbol here, are PWM output. So you can use any of this to work with the servo. Okay, so I will choose pin number 5 one more time. I will attach it here. I will change the color. It will be yellow. So what we're going to do here is to first, we have to include the servo library, which I already include here on the top of this project, okay? And then we can also declare the servo. So as it's using the same pin as the lad was using, I have to comment this. And here I will say servo, and then I'll call it my servo. That's it. Just semicolon here. And here I have to comment because I'm not using the LED anymore. And to declare my servo here, I have to use my servo dot attach, and then I have to say the name of the pin I'm using. Okay, that's it. Now, instead of analog write, as we are working with the servo, we have to use the function write, my servo dot write, and then I can put status here. But status is working with a range that goes from 0 to 255, and the servo motor works with a range that goes from 0 to 180. So to control the servo, we have to change this range here. Okay, so status is receiving values from the potentiometer that are values that goes from 0 to 1024, and has to transform these values to new values that goes from 0 to 180, that are values that the servo motor accepts. So now, if we initiate the simulation, we are controlling the servo motor with the potentiometer. Can you see here? So 0 and 180. So that's the idea of today's class. You know now how to use the analog write since last week. But today you learn how to transform values using the map function, and also how to read values from the analog pins that are these ones that goes from A0 to A5. Okay, and you also learn how to use the servo. You know now that you have to include the library servo. You have to create an instance of servo. So this servo here with capital letter is the class servo, and here you are creating an instance of this class, which I called my servo. So now my servo has all the built-in functions of the servo library, of the servo class. That's why here we have the attach function, and here we have also the write function. Okay, and here we are writing the value of status that we know that are values that goes from 0 to 180. Okay, forgive me for the mistakes during this class. I don't know what happened in the first part, but that's it. Okay, I hope you have enjoyed, and if you have any questions, you can type here or turn on your mic. Leonard, your hand is raised. Would you like to ask something? No questions? Thank you, Tochuku. Okay, so I'll finish this class. And next week we're going to have our last class together. So in our next class you are going to learn how to use new stuff, okay, that don't depend on the commands analog write, analog read. We're going to use probably the ultrasonic sensor and something else. Okay, any assignment maybe during the week. Okay, Tochuku. Okay, guys, see you. Thank you one more time. Thank you, Nathaniel. Goodbye.